In this video, I introduce list squares GAN. Regular GANs use the loss function V to train generative models. The first term is used to penalize probabilistic false negatives, while the second term is used to penalize probabilistic false positives, which leads to vanishing gradient problem during training. Here is the architecture of a regular GAN. His discriminator is used as a classifier. For binary coding scheme, the discriminator outputs 1 if his input is sampled from real data. For AB coding scheme, the discriminator outputs B if his input is sampled from a real data distribution. For binary coding scheme, the discriminator outputs 0 if his input is sampled from a model distribution. For the AB coding scheme, the discriminator outputs A if his input is sampled from the model distribution PG. List squares GAN uses the list squares loss function to minimize the Pearson X square divergence to train the generator. Suppose that the AB coding scheme is used for the discriminator. A and B are the labels of fake sample and real data respectively. Areas GAN objective function is defined as sum of two terms. Here we use equation dx is equal to b. We get this list squares. By properly selecting A, B, and C, we use this loss function to train the generator. We got two benefits. The first one is this squares avoids gradient vanishing. Second, the squared loss is in favor of outer layers with a large gradient, which are explained graphically in these figures. Using the AB coding scheme, the optimal discriminator D prime is expressed in this formulation. If selecting B minus C is 1 and B minus A is 2, areas GAN is equivalent to the F divergence GAN. We train the generator G of areas GAN using Pearson X square divergence as a loss function C, which can be expressed as Pearson X square divergence here. For example, setting B is same as C and A 0. And then now we can rewrite this optimal discriminator as in this formulation, which is the same as the regular GAN. And then now we have a loss function to train the discriminator and use this loss function to train the generator. For more details, please check with these references. Thank you. Bye.